This is a Sharp Inverter mini split air conditioner that came to me for repair. I have turned on the unit. The H has started to display on its display. It has started to consume 0.1 kilowatts. The outdoor unit has started to work. You will see that the kilowatts on the display will start to increase as the outdoor unit has started. Now the kilowatts has started to increase, and they will keep increasing as the compressor has started to increase the speed. The kilowatts are also increasing. It has begun to consume 1100 watts. It is cooling absolutely fine at 1100 watts. It is consuming 5.4 amperes. It should consume a total of 7 amperes at full speed. Now it has started to consume more kilowatts. As now I am shooting the video, it has begun to consume more kilowatts. It has started to consume 8 amperes. As I shooting the video, it is not showing the problem, and here we go, it has begun to decrease the kilowatts and the amperes. And this is the problem with it. The wattage will gradually keep decreasing, whether you use it at any program. It started to decrease kilowatts more. I got to know it by the compressor's sound. And a time will come when the unit will stop completely. Now I have removed the cover of the indoor unit. And let me tell you what could be the first possible fault in this unit. 3 thermistors or sensors are installed on the indoor unit. The yellow wired is the room temperature thermistor. This black wire is the pipe coil thermistor, which detects the temperature of the evaporator. This orange wired coil thermistor detects the cooling coming from the outdoor unit expansion valve inside the evaporator. So someone has installed these sensors in the wrong pipe. The black has been inserted down and the orange in the upward pipe. I will insert the black in the upper side of the pipe, and the orange at the bottom pipe. Next, I will check its thermistor values. I have dipped all the indoor thermistors in the water. The temperature of the water is 26.2 degrees. 4.18 kilo ohm is the value of the black wired thermistor, which is fine at 26 degrees. Now I will check the value of the yellow wired pipe coil thermistor. Its value is almost 10 kilo ohms. Its value is also good at this temperature. Now I will check the last orange pipe coil thermistor of the indoor unit. Its value is also 4.19 kilo ohms. This value is also fine. Now, I will start the unit again as I place the coil thermistor in its correct pipe. It has turned on, and the unit is working on the L2 program. We will leave it and check how it functions. It will start to consume amperes when the compressor starts. Now, the unit has started to consume power. It is consuming 2.9 amperes. This is the outdoor unit. I have attached the manifold gauge with the unit, to keep an eye on the refrigerant pressure. The air conditioner has been running for 10 minutes. It is working on the L2 program. First, it was consuming more amperes on the L2 program, and now the amperes have started to decrease. It is consuming 3.9 amperes. It is taking 800 watts. I will set it to the H setting. Now let's check whether it increases the watts or not. It has started to increase the kilowatt. And after a minute, it again started to decrease amperes, as the inverter unit decreased amperes when the cooling in the room completes to the set temperature. I have opened the outdoor unit cover, and I am finding a problem in the outdoor unit, whether the problem in the motherboard or any thermistor is bad. 4 thermistors are installed in this outdoor unit. Some Sharp outdoor air conditioners has 5 thermistors also. The red thermistor is for the discharge pipe. It is installed in its perfect position. It seems not to be problematic. This green thermistor is an outdoor temperature sensor, which is attached in its proper place. The black is the suction pipe thermistor. It is also attached to its proper pipe. The last thermistor is the orange one. This is the discharge pipe, and as this is only a cool model Sharp inverter split air conditioner, the discharge pipe is moving downward and then moves upward. The orange thermistor is again installed over here. This thermistor is for the condenser pipe. It's not for the discharge pipe. Someone has installed it in the wrong place. The refrigerant flows through this return pipe, and then the expansion valve is installed, where the refrigerant expands and goes inside the indoor evaporator or the liquid line. This sensor is installed in the wrong place. This air conditioner was shifted in winter from one place to another. When they tested this unit at that time, it worked fine. When they run the unit in summer, the unit starts to consume power, and then gradually, after decreasing the consumption, the unit completely stops working. I will remove this thermistor now and will install it in its correct place. It will be installed before the expansion valve. As I have installed it in its correct position, I have installed the cable ties on the thermistor to not let it fall due to vibration. I will put the AC cover back. I have fit the cover of the unit back. I have started the indoor unit. I will use it program. The compressor has started to work. The indoor unit has also started showing power consumption. The compressor has also started consuming almost 4 amperes and consuming 1000 watts. It has started to increase the power consumption with 5.4 amperage. The thermistor or pipe coil sensor I corrected was of the condenser. The refrigerant that flows through the condenser cools down and goes out through the pipe where I corrected the thermistor. That thermistor measures the temperature of the condenser. As the thermistor was fitted at the wrong place, the thermistor which was attached to the wrong pipe used to get hot, and this is why it started to decrease the amperes only after 5 to 10 minutes of working. And when that thermistor started to heat more than what was required, it also stopped the complete unit. The motherboard thought that the condenser was heating up a lot. This was the reason for this problem. See, it is consuming 2 kilowatts of electricity now, which it was not consuming before. Now it does not decrease the ampere in reverse in just a few minutes or seconds. The compressor is consuming 8.6 amperes. The problem has been fixed. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.